In this next application, we have a restaurant manager who wants to purchase 200 sets of dishes. One design costs $15 per set, while another costs $45 per set. If she wants to use her entire budget of $4,800, how many of each design should be ordered? Well, in order to answer this question, we're going to set up a system of linear equations, and we'll organize the information that's given in this scenario in a tabular form. So if we scan this problem again, the first number we come across is talking about the number of sets of dishes. This next number is talking about the dollar value of the set. So we have two different categories of information that we'll account for. So one category is the number of sets, and the other set of numbers deal with the dollar value. We have two different sets of dishes, set A and set B. We'll also need a column for the total number of dishes. So when we read back, it says that the restaurant manager wants to purchase 200 sets. So that number reveals the total. So our total number is 200, and that total comes from purchasing set A added to set B, and that should equal 200 sets of dishes. So we can already see one equation right there. Then we're going to take in the dollar value for these sets. One design costs $15 per set, the other is $45 per set. So just going in order, since $15 is mentioned first, $15 multiplied by the number of set A added to $45 multiplied by the number of set B should equal the total dollar value. The budget is given at $4,800, so there's our total. We can see that we now have a system consisting of A plus B equals 200, and 15A plus 45B equals 4,800. We can use either substitution or elimination to solve this system. So I will take this first equation and rewrite that as B equals negative A plus 200. All I'm doing is subtracting A from each side of the equation. This gives me negative A plus 200 to substitute for B into the other linear equation. We now have 15A plus 45 times negative A plus 200 equals 4,800. Notice now we have one equation in one variable, so we should be able to solve for A. 15A, 45 distributed to each of the terms in the quantity. That gives us negative 45A for the first term, and then a positive times a positive means we will be adding our next term. So the product of 45 times 200 is 9,000. Z equal to 4,800. Now to solve for A, we're collecting our like terms. These two terms are variable terms in A, so those are like terms. And notice that 9,000 is not a variable, so we'll need to subtract 9,000 from each side of our equation. When I combine 15A minus 45A, I'll have negative 30A on the left side of the equation, and 4,800 minus 9,000 gives negative 4,200. To finish solving for A, you can notice that negative 30 is connected by multiplication. So to undo that multiplication, I'll divide each side by negative 30. A negative 30 divided by negative 30 makes positive 1a, or simply a. On the right-hand side, I also have a negative divided by a negative. So I'm going to take 4,200, divide that by 30, and that equals 140. If we go back to the table, we can figure out what we just solved. A represents the $15 set. So we would need 140 sets at the $15 price. We still need to solve for B. So going back to the original system, it looks like this first equation would be a little easier to work with. So I'm going to go back to A plus B equals 200. If I already know that A is worth 140, I can substitute that for A. 140 plus B equals 200. And simply subtract 140 from each side of this equation to solve for B. B now equals 60 sets at the $45 price.